Lecture 9. This means we are getting closer to the end of class. And today we're going to talk about some choices that you might have to face. And we're not talking about having a right choice or a wrong choice. If you had a set of data and you gave it to two different data scientists, you might get two different analyses. Why might they be different? Perhaps it's because how they took the model assumptions or how serious they thought they were, certain skill sets or what approach they like to use, and priorities for the project. The question is, who's got the right one? What conclusion are we supposed to draw from having two different answers? And quite often the answer is it doesn't necessarily matter. It's okay for the analyses to be a little different based off the goals of the client. If your goal is to make a prediction and both models are doing well, who cares that they're different models if they're doing the prediction well? It's entirely possible that either one is fine, and it doesn't really matter. If it does matter, let's talk about what the goal is. Do we need the model to follow some specific form? So here's an example. Look at these purple dots. Imagine in your head that you had to predict what happens here at the black line. Notice there's kind of a gap where that black line would be. How would you make a prediction here? Well, we could do a straight line and predict right there. If you felt like the x values had some error, you might do orthogonal regression. Think of it as like a principal components approach. It'll alter the line slightly, change your prediction. You might see the purple dots kind of curving here because it looks like it's going up right here, but not so much there. Maybe there's a curve, but it's all the way along, like a time series wave. Or could it be that what you're seeing as a wave is really just going up and then dropping back, going up, drop, right? So piecewise, these are four different models. And for the prediction right here, there's kind of a range there. Is that range a lot? Well, I don't know. It kind of matters. If we look down here, if our goal was to predict in this area, all the models pretty much agree. So that seems fine. Is this error enough to say that we're going to stress about which model? Look over here. If we went outside the range of the data, like we need to predict next year, it could be which model we use has a huge difference. Okay, so now let's talk about why are they different and which one seems to fit better with the experts or what they believe. These are choices that you'd have to make. It's going to affect your decision, and whether you care is going to matter on what your goal is. We have already talked about a bunch of choices you might have to make, such as how are you going to get paid, how do you negotiate or work with someone when there's conflict, predictions versus model, we just barely talked about that. And that might be an explanatory versus confirmatory type study issue. Do you want money or time? Theory or results? This class, we're going to try to say, let's focus on the results because a lot of other classes say focus on the theory. What does the client need? Where do they want you to go? AIC versus BIC, I think that was like last week. Main effects or interaction, we're actually going to talk a little bit more about that later this week or later in this lesson. Outliers, should you delete them? Are they representing what you really want to study? Blinding and missing data, do you leave them? Do you impute them? Do you just delete those rows? And the answer is going to depend on the scenario, on the situation. What is your role within the company? These are all things we've talked about at length. Decisions where the answer is it depends. Another one that we have already talked about is which program do you like to use? I think there's three main things people want to look for in a statistical program. Something that's inexpensive, something that's powerful, and something that's easy. Problem is this, perfect all three area right here. I don't think you're going to find any programs that fit in there. If you want cheap, Excel's cheap because most people have it. Crunchit is a super easy program to use. Dr. West, who is actually a friend of mine, has made that. Powerful, like SAS, Mathematica, okay. Powerful and inexpensive, R would fit in there. Inexpensive and easy, OpenStat is that way. It's not as powerful though. Powerful and easy, SPSS, Minitab. Now Stata's here. It used to be that Stata was kind of over here, inexpensive and also easy, but not as powerful. They have moved Stata to be more powerful, which is great. It has become more expensive as it grows in power. R is not as easy to learn, so R Commander is a way to try to make it more point and click. Most people that I've talked to haven't been all that impressed with it. So go ahead and fill out statistical programs. I think last week we were talking about which program do you like the best. This week, come up with a new one that could also be in this list. And tell me, where does it fit? Is it powerful but not expensive, or where? Which program should you use? The answer is the program you have, all right? And for some people, that's R because it's uh, easy to download. But maybe you don't know how to use R, which is why some people use Excel. Or maybe it's the program that does what you need. That's why we don't use Excel. That's why statisticians cringe, because just try to make a histogram and you'll understand. Or maybe you actually have rules about which one to use. SAS, for example, to do pharmaceutical research for government pipeline programs, SAS is required, and I'll explain why in just a second. So despite all that we've talked about which programs and which one's better and which one do we like, it's okay for you to use whatever program works within your budget and works within what your company's doing, whatever else. It's entirely possible they'll make you learn, Ruby or some other weird program. And you'll be like, okay, this is what we're using. This is what I'll figure out. That's all right. About 20 years ago, there were lots of fights about R versus SAS because these were the two programs. I think Python now should probably move in and join the fight. But R was cool because it was open, so everybody could go there and make some package, and whatever your research is doing, this will help do the stuff that I'm saying you should be doing and better. And it was free and it's fairly easy to get and use. SAS, on the other hand, says, no, we're the professionals. You're doing serious statistics, you need to have SAS. Lots of jobs want it. There's lots of great tools. The help manuals are so good. I've actually taken stat classes where the textbook for the class was a SAS manual. That good. And the warranty is kind of a big deal. This is why pharmaceutical companies require the use of SAS, because if something goes wrong and it's because of the program, SAS steps in and they'll actually pay for it. Before you say, wow, it sounds like SAS is fantastic, you should know that it's a whole lot of different procs, and each proc is sort of like a mini little program. They all run very differently. If you have random effects in your model, these are all different procs you might use to get different pieces of that, depending on whether you're trying to analyze the variance components or whether you want the model form or to make predictions or all these different things. This is starting to get outdated. SAS is actually working on making Proc Mixed be the winner that does all the stuff the other guys do and does it better. But when I was in grad school, I had to learn all these different procs, and every one of them was just completely different in the way it worked. And let's talk price. It's actually hard to find the price. This is from 2014. That was the best I could get. Wow. Wow, that's how much it costs for you to get your own personal thing of SAS in your home. And the company's like, don't look at those prices, contact us and we'll try to work out something with you. Well, when you're starting at $8,000, I don't know how this negotiation is ever going to get to the $5 I'm willing to pay for a stat program. So that can be prohibitive, but again, some companies like it because of the warranty and the guarantee, and they've got some top level professionals working for the company, so it depends on what level of research organization you're working with. By the way, as a last note, here is the code I used to run my master's project on proteomics with mass spectrometry data, and I felt very proud of it. But it did take some time digging into how the program works, and it ran fast and it ran well, and I got fantastic answers. I used the school's license for it.